Good afternoon, everyone. We'll be beginning the webinar. Thank you for joining us for Allied Vision's second ITS webinar in regards to will camera technology combining ANPR become a standard ITS data sensor. I am Francis Obenamaler. Jorgen Pedersen will be providing this presentation or giving this presentation, but we'd like to thank you guys again for joining us. And without further ado, let me turn it over to Jorgen.
Thank you, Francis, and hello, everybody. I can see we've got some friends on from mainly North America this time, but earlier on we were joined by our friends from Asia and Europe. A quick overview of what we'll be discussing today. I am going to change it a little bit. When we started putting this together, when I sent out the notifications, we were talking mainly about ANPR. As I did more research and became more aware of what was happening, I think it just really needs to be how camera technologies can be used as a standard ITS data sensor, because bear in mind that ANPR is just one of the elements that can actually identify different vehicles, etc. So today there's not that many slides. There's only about 15 odd slides, which is a lot less than there was last time, but those slides are pretty busy. So anybody that knows me knows I don't read those slides. So if you have any questions, please just drop an email or drop a message over to Francis. I'll give him something to do for a change, and he can ask the questions as they come up. And let's keep this a little interactive and a little light-hearted and move forward. Now I'm right in assuming that the presentations are being displayed on the website, and the webinar presentation itself is being displayed on the website, right? And I also believe the question and answers from the previous one are also up now as well. Is that right, Francis?
That's correct. You should be able to access the first webinar on our website, but then also this webinar today will be on our website as well. So.
Just a little word on that. We've already had quite a few questions come up, which I'll be going through as we move through the webinar. Those answers to those questions won't be available until the new year, I'm afraid. Obviously, we're winding down to the Christmas period, or the holiday period, I should say, and it probably won't be done before the new year. Anyway, without further ado, let's get started. What I'm going to go through today is a bit of an overview of the current technologies being used, and any of you that saw my previous presentation will know a little bit about that. I'll go into a little bit more detail today. And really an insight of where traditional cameras have traditionally been used in ITS, and look to the future where it's probably going to head. Now, if we head to the area that I'm looking at in terms of this is what may happen, I think we also need to identify how a sustainable system could be implemented within ITS. And the reason I say that is because there are other changes to technology that must also happen in line with what we're discussing here. As a result, I'll go through the issues that camera technologies will face. I look at the short-term future, and it is really short-term. We're looking at probably 12 months to 24 months, and probably less than that in reality out at this point. And then we'll go through some of the challenges again and the conclusion at the end of that. Quick overview of what ITS means. ITS is Intelligent Transportation Solutions, and I'll put this up on every one of my slides just to keep it focused on this. But that really is everything to do with every mode of transport. So that's traffic, transit, ferries, airports, autonomous vehicles, mapping technologies, or street mapping technologies at the very least, and pretty much walking, cycling, and anything else you can pretty much think of. It is really the quintessential product of how to get from A to B. So moving forward, I'm going to have a look at the current technologies now, and I'm going to go into this in a little bit of detail because I think it's important to understand where they're failing and where they're perhaps not providing the level of detail we need from an ITS system point of view. I've separated it into general and specific, and to be clear, these are not ITS terms. General, I'm relating to those that can identify vehicles but not a specific vehicle, and specific is obviously the opposite, where they can identify specific vehicles. And the first ones we're going to go through are the general. And loops, as we discussed at the last webinar, are probably the most prevalent. Well, they are the most prevalent by a long, long way. The two examples you see in front of you are both signalized intersections with loops as detectors. And one of the questions we had at the last webinar was, how many loops do they need to actually get an inductive coil? And the answer to that is actually 2. I did look into that, and and you can actually see the inductive coil on the right-hand side as it would normally be delivered. Now loops are great. They can be anything which is vaguely loop-shaped, so it can be circular, square, octagonal, even triangular. They can, as long as it effectively forms a loop, it will work. The next technology I want to discuss are the magnetic pucks. And to be clear, these are all images from the Census website, although, again, to be clear, there are other magnetic pucks on the marketplace as well. Census is probably the most prevalent of those. But essentially, they are the same technology in just a smaller package. The advantage of the magnetic puck is that it can actually communicate via a wireless device back to a back-end system or to a relay system, which then goes back from that. But essentially speaking, they are the same. And they also suffer because of that for the same issues. And the main issue is that they're in a very hostile environment. You're actually digging a hole or a channel in a road. You're sucking out all the grit from that channel or that hole. You're embedding your device in there or your cable in there. And then you're effectively putting some kind of sealant on top of that. And of course, the problem with that is if it's anything above 2 inches, that's likely to be ground off as you repave your road. So it's it won't. Your repaving or your grinding machines will not differentiate between the loop and the real tarmac. The other one, which is very prevalently used, is radar. And radar you can see being used for anything from speed enforcement, from the right-hand picture, to pure data collection, the middle picture. I've even seen them being used in parking management systems. And that's something we haven't spoken much about on this particular presentation. But one of the advantages of a radar is that it'll cover multiple lanes. It'll even cover both directions of a freeway simultaneously. But it has to be mounted pretty high. If it's mounted lower, you can see by the sort of graphic image on the left. If it's mounted lower, any high-sided vehicle will actually shadow or called shadowing of any vehicle that's running beside it, and you just won't get a true reflection of what's happening on that road system. So,
We have a question.
oh, we have a question. Sorry. Keep those questions coming, please.
Okay. Well, this question asks, you've separated loops and magnetic pucks, but aren't they essentially the same thing?
They are. They are very similar. The only real difference is that obviously you're digging a fairly small hole in the road to digging a fairly large channel. One actually has a wireless device, and the other one has a roadside receiver. But yeah, they are essentially the same things. So looking at the specific vehicle identification technologies, the obvious one is, and the first one I'm going to go through is Bluetooth, but it wasn't the first to be developed. Bluetooth was actually developed to test the data coming from GFVD, GPS floating vehicle data. And it was developed by the Maryland University for the I-95 Coalition Corridor. And the idea behind it was anything with a Bluetooth device, and at the bottom of it says Bluetooth signals come from cell phones, PDA, laptops, GPS, car radios. The fact of the matter is it shows how old the technology is because nobody uses PDAs anymore. And I've got to be honest, I've never known of a Bluetooth signal being coming from a car radio. But the fact of the matter is it comes from a variety of different devices. The car itself actually has Bluetooth now. And as it goes past one receiver, it'll identify the time. As it goes past the second, which you know the distance apart, and in this case, in this graphic, it's 2 miles, you can identify the time of the next one. From the distance traveled on the time, you can identify the speed of the vehicle. It's very, very simple technology. Now, the big issues with that are when you have a busload of kids going down, where you've got 50 kids in a bus or 50 adults in a bus, for that matter, all of which have 1 or 2 cell phones, you get, shall we say, a mismatch of what's really happening. If you have somebody walking beside the freeway or walking beside a frontage road close to the freeway, that will also pick up their signal, and again you have all these outliers which have to be removed at the same time. So looking at the floating vehicle data now, basically the idea between floating vehicle data is when you have tracking devices on vehicles, or when there are tracking devices on vehicles, what they effectively do is every minute or every 3 minutes or however long the interval is, it sends back a signal saying I am here. By identifying where you are, and identifying the next where you are, and the next one, you can effectively create a daisy chain. of what that vehicle is doing along a road network. You can effectively plug it to a map. And as you can see on this example, when the vehicle is traveling quickly, they're quite far, their space quite far apart, and when it's traveling slowly, they get closer together. And it's relatively simple technology, and it's relatively effective in all fairness. It's just reasonably expensive. The next one is cellular floating vehicle data. And what you can see here, or the graphic is trying to show you, are the hexagonal elements on here are effectively cell towers. And a cell tower would generally span something like 1,000 meters, 1,000 yards. And every time it goes from one cell tower, you go from one cell tower to another cell tower, you have a crossover point. And that crossover point identifies that, okay, this cell phone is moving from here to here, and the next one is again. And by actually pulling those all together, you can identify the passage of a vehicle. The issue you have, unfortunately, is when you have a frontage road beside that. And I've just used a graphic from the previous slide to demonstrate this. But you can see that actually it goes through most of exactly the same cell points as the other road would. And therefore you can't really differentiate which road you're on. So effectively what it's doing is aggregating that data together, and it's not particularly efficient because of that. Two other examples I want to give in terms of its limitations are when you have an urban environment, a city block may span 1,000 meters, as I said, and therefore it could actually cover 3, 4, or 5 roads back potentially, which clearly doesn't really give you the kind of information that you really want. Another example would be if you have, say, a mountain pass, it could actually meander through the same cell areas multiple times and give you a false reading. But to be clear, all of these technologies are very effective. They have limitations, but they're, again, to be blunt, every current ITS sensor has a limitation of some description or other. The last one I want to hit before we actually start looking at the camera in specific and why the camera is different to all these is the toll tag readers. And toll tags are used throughout the world now. This one is showing, it's actually from the EasyPass website. It actually shows a great graphic of what actually happens. The transponder is affixed to the windscreen as it goes under a gantry, identifies the vehicle, and then there's a traffic monitoring camera above that, just in case the vehicle fails to read the transponder or the transponder fails to read the vehicle. And the point with that is, whilst these are very effective, they are generally only used on toll roads, and as a result, you really can't use them anywhere else. Now, there are places, such as New York City as an example, who have put toll tag readers up in various areas to try and get a better indication of what's happening. But that's unusual, I'll put it that way.
We have a question here. This question states, now for floating vehicle data, you haven't mentioned mobile applications or crowdsourced information. Do these not play a part?
Yeah, and that's a really good question, actually. And both of those do play a part. Certainly, some of the likes of the larger organizations, Google, Amazon, are collecting data through mobile applications and actually doing it very, very well. And most of the Google Maps you see will actually use that data to demonstrate what's really happening on that road network. The biggest issue you have is you can't just buy that data and then use it. You have to use the whole Google map if you want to. And that really is a limitation of what they're providing. When we're talking about ITS, we really want to be in control of our own destiny and therefore be in control of the data we're receiving and be able to manipulate that data as we need to. And that's what you can't do, which is why that wasn't included. But the crowdsourced one's an interesting one, and probably the most prevalent, most well-known crowdsourced application is Waze. That was bought by Google, I think it was last year. It could have been this year, though. I can't honestly remember. But basically what it does is allows a set of users to identify what's happening on the road network by pressing a button on their mobile phone and saying, okay, there's debris in the road here, there's a slowdown here, there's congestion here, there's an accident here, or whatever. And by pulling all that data together, you can effectively start building up a fairly precise overview of what's happening on the road network. I can certainly see that crowdsourced technologies will play a really big part as we move forward. Very good question. Keep those questions coming, please. So looking at the traditional ITS camera applications, what I've tried to do here is map out the processes as we've moved forward from where we started to and where we're going to. And I think the first ITS applications were mainly around the enforcement. And they were around speed enforcement, red light enforcement, and as the packages became smaller, we started to see those emerge, those appearing in police cars to look for stolen vehicles primarily, or to look for vehicles of interest, should we say. And that's where we really started. Once we got to a point where that was working reasonably well, we then went to the revenue collection elements. And the top picture of here you can really see was the traditional toll booth where you go in, or you drive up, you pay your money, you can move on. And ANPR applications and camera applications were particularly used to just identify any vehicles that fail to stop and pay. And they're relatively slow-moving vehicles, they're in a controlled environment. It wasn't particularly hard. Having said that, that was probably at that time the major capabilities of that camera. As processing speeds increased and as ANPR software applications improved, we were able to actually put those on open road tolling environments. And that's the second picture here, which basically shows a tolling environment where you don't have to stop. On this particular one, you do have to slow down. I think the average speeds are between 40 and 60 miles an hour, but you slow down. It takes your electronic wallet, it takes a deduction from your electronic wallet, and you proceed as if there was nothing in your way. And again, that's all governed by toll tag readers and then camera applications to back those up in the event of a failure to read. The bottom one, which is probably the most exciting, is really the hot lane kind of applications that are now, or hot lane environments that are now starting to be delivered. And this one at the bottom here is actually part of the I-95 around the Washington, Dulles area. And basically you can see that what they're effectively trying to do is, from hot lanes, is charge you for the distance you travel, the time of day you travel, and potentially even the congestion that's on that piece of road at any one time. So as an example, you could actually increase the price based on how much congestion there's there to dissuade people from using it if it's already at peak flow capacities. And I think that's something you're going to see a lot more of as we move forward. The next one is really infrastructure management. And to be clear, infrastructure management and revenue collection systems pretty much came in parallel to each other. The first one is a tunneling system, the second one's a bridge environment, and the third one's signalized intersections. And each of those uses cameras to huge effect now. The first one, you're effectively, in tunnel environments, you're effectively using it for speed. You're using it to identify overheight vehicles, and you're actually using it also, one of the major elements of camera technology is also to identify hotspots on vehicles, and that's really a result of some of the issues that have occurred in Switzerland with quite a few people unfortunately losing their lives because of a fire in a tunnel, and likewise in the Channel Tunnel also had a fire. So all vehicles are now being monitored before they enter the tunnel, and any hotspots they can actually pull that vehicle off and just check that it's okay or not. Signalized intersections at the bottom are used, cameras used extensively now to actually identify the turning movements of vehicles, as well as the loops themselves, so you can use both. The next area is congestion management. I'm going to actually call it congestion mitigation, because I think this is really where ITS starts to really play a really big part. The top picture is actually something you see quite prevalent in Britain now. That's really speed over distance cameras. So you've set up cameras to identify not only spot speeds, but also speed over a particular distance. So there may be another one of these gantries a mile down the road, and another a mile, and another a mile. And what it does is keeps people honest, one of a better way of phrasing it. It effectively prevents people from going through them slowly and speeding up and going through the next one slowly. If over the course of the distance you actually exceeded the speed limit, you will get fined. Now, it's not about fining though, and I want to be clear about that. It is about managing the speed of vehicles and therefore the flow of vehicles on the roads. So the bottom picture is actually a variable speed control, also in Britain. And basically what it shows is that you've got a gantry. It's identified that the average, the speed you should be going is 40. And I know, Francis and I were discussing this earlier, and we both cheated. And we both, you tend to go through these at 40 and then speed up to 60 if you can. Absolutely. And then go here and then go through the next one at 40. And the idea of the top one is to prevent the bottom one from happening. So I can really see a real need for variable speed controls and speed over distance happening in harmony with each other. And I think that will happen. Well, I already know it's happening, and it will happen in a big way as we move forward. The middle picture, I think, is also really quite interesting, though, as well. It actually shows a lane control system. And the idea behind it is that in the morning, you get a flow of vehicles in one direction. In the evening, you get a flow of vehicles in the other direction. And actually, you have quite a lot of availability but in the wrong direction. And the idea is to start using those lanes effectively to move vehicles in the opposite direction. It's really as simple as that. Next one is safety management, and I think this is really where ITS is going to have to show some real improvements in what's really happening on our road networks. The first one is, one of a better way of phrasing, debris in road. Now, normally debris in road would relate to a tyre, a dead animal, a fridge that's fallen off the back of a truck, a box, not a mountain. Obviously, the mountain is a big debris in road element, but it actually amounts to the same thing. The fact of the matter is, it doesn't matter what it is. If you have a lane obstruction, you can have cameras that automatically identify what they are, not what the obstruction is, but that there is an obstruction. Flag it to an operator, and the operator will actually then start putting mitigation plans in place. In this case, they'll actually close the road. But the second one is obviously overheight vehicles, and it's staggering how many overheight vehicles hit bridges and overpasses every year, and it still hits them. But the fact of the matter is, it's a problem. It's a problem that can be fixed pretty easily through camera technology, and it just needs to happen, and it will happen as we move forward. And I was quite lucky to have worked on one system to actually look at debris in road, and I think 160 odd cameras were implemented over a several mile stretch just to identify what was really happening on that road network. The last one is actually equally as important, and probably more important as we move forward, is automatic incident detection. And the idea behind that is, if you have a body of cameras, they'll be able to identify when slowdowns occur and even when an incident's actually occurred. And the same camera that's used for debris in road will be used for incident detection. I mean, it's pretty straightforward stuff. And then we look at the future systems. We have drone technology, I think, may play a part, and certainly you'll be used for cameras, but and I can certainly see that drone technology will be used for ITS applications as we move forward. The second one is street mapping and street views, and the third one's the autonomous vehicles. And none of these are, well, the middle one with the exception, but the other two are not likely to happen in the short term, but I'm pretty sure they will happen.
Oh, we have a question here. Now, why haven't you included applications such as congestion charging, freight overcharging, or weigh-in motion?
Again, thank you very much for the questions. The reason I didn't include congestion charging is because it's really quite similar to tolling environments. They really are. They are tolling environments, for want of a better way of phrasing it. Certainly the London congestion charging system is a tolling system between the hours of, I think it's 7 and 7, but I could be wrong about that now. Likewise, Singapore is pretty much the same. Stockholm's a bit different because that takes more of the model of the hot lane charging. So you can be charged by the time of day, a different charge. And I think you can actually even be charged in Stockholm based on the vehicle classification as well. But again, I could be wrong about that. So that's why I haven't included those. Train user charging, again, is a tolling system, just identifying the vehicle type as opposed to identifying the specific vehicle. And again, those are being trialed around the world at the moment, and certainly it will be. The technology is the same, essentially. Overheight vehicle detection, was that, no, weigh in motion, you said. Weigh in motion, yes. Was the other one. And again, that's, the reason that wasn't included is because while cameras play a part, it's really a situation that weigh in motion requires scales as a primary data source and then cameras as a secondary, and that's why that wasn't included. But they're all very, very good points, and Cameras play a part in each and every one of those. So have a quick look at the future of cameras and potentially ANPR applications. Certainly the speed, occupancy, volume, and vehicle classification can be done through a camera, so can wrong way running and debris on road, and a whole host of other applications as well. And the reason I changed this at the beginning to say it wasn't just about ANPR is because I've actually, in researching this a bit more, I've actually come across two companies who, because of ANPR issues in some geographies, have actually gone away from ANPR and are actually identifying specific vehicles using camera technologies without identifying the number plate. And one of them is doing it by using hash codes instead and converts the number plate to 120, through 128-bit encryption, and delivers you a string which is huge but can actually be identified but not identify the specific vehicle. It's quite clever. And the second one will actually identify the vehicle type and elements of that vehicle to identify the vehicle specifically. And it's really quite interesting, and it's a different approach, but actually one which I think will prevent some of the privacy type questions that have been being raised. I'm not sure that's English, but anyway, forgive me. It's been a long day. Some of the new systems, though, is I really want to hit the tolling environment first of all. I believe there's an opportunity here to actually change tolling environments and actually have transponder-less or non-transponded tolling environments. And actually, when I first put an idea together for this, I was told by one organization that I was mad. And then shortly after that, thereafter, and I think it was within 24 hours thereafter, I actually found an organization already doing this on a big scale, actually covering an entire country. But the idea behind it is every tolling, not every, but a lot of tolling systems have different transponder requirements or transponder networks. So I think there's 15 different tolling environments in North America. When I went to Southeast Asia, there were actually a lot more than that in a much more compressed area. And the problem with that is you end up having to have, if you wanted to have a trucking company that travels all across North America, you'd need 15 different transponders on there. And that just isn't efficient. It's not, you know, and each of those would have to have its own electronic wallet and It's just not nice. When you consider that one of the environments I've been investigating actually has a 99.2% read rate of all number plates over a multi-year period, across all weather conditions, including rain, snow, fog, hail, etc. That is actually equally as good, if not better, than a transponder read. So it can be done, and I certainly see that actually as we move forward it probably will be done. Some of the other areas are obviously security. At the bottom right-hand corner you can see what we call in North America an Amber Alert. This is a child abduction or a child gone missing. You also have silver alerts when an old person has going missing or gone AWOL. And the idea is that using cameras with ANPR or with identification properties, you can identify where the vehicle is and effectively track that vehicle to the point where it can be stopped or at least monitored. But some of the other ones, the safety issues, the top, the other two images here, the bottom left one is the one I'm really going to talk about. But what you can see here is a freeway environment from a dash cam. And you can see that what's actually happening here is a vehicle's traveling along a freeway in the wrong direction. With the kind of technology we're talking about here and with some of the automation that we will be talking about, what could happen here is all the way down this freeway you could actually have, until that vehicle is stopped, you could have the dot matrix signs telling vehicles to pull off and get out of the way. And then we could come to the smart operations, and this is a typical picture of a traffic management center. Basically you have an operator manning 1, 2 or anything up to 6 screens I've seen, and in front of them or somewhere in that traffic management center you have a video wall of however many images you can display. The point is that in reality that operator doesn't really look up. That operator is really very busy on doing whatever they need to do in front of them, and even if they do look up, the fact of the matter is they're seeing perhaps 16 different images, they may have 300 different cameras out on the network, and they can't possibly monitor them all. So the idea behind this is to have some operator flagging, some automated analysis, and from that be able to actually identify what's going on to the operator as they need it.
We have a question. Could you please describe just a little bit more about operator flagging?
Yeah, sure. Yeah, I should have been going into that a little bit more detail, so thanks for reminding me. The idea is that if you do some pre-processing on the data you're getting from any sensor, whether it's a camera or anything else, that could automatically flag to the operator an issue which is occurring. So, for instance, wrong way running, you could have a red screen pop up identifying that there is a problem on that particular road and what that problem is. I will just say a little bit more, if that's okay, about the automation as well, because the idea behind it is not only will you flag to the operator, but the system will be intelligent enough to be able to bring up the right images at the time, and even potentially bring up the decision support system, identifying what the courses of action should potentially be. But some of those limitations of the current systems, though, are, a lot of these advanced traffic management systems, the ATMS systems, are fairly proprietary. They're not used to having this collection of data coming at them. They're used to collecting data in the traditional ways, which doesn't necessarily have the quality or quantity of data that you'd otherwise see from what we're proposing here. As I said, there is limited intelligence. Despite the fact that ITS stands for Intelligent Transportation Solutions, there is limited intelligence on there. And some of that could be through the inability to trust the data they're going to get, the inability to trust the decision support systems. But I have to say that is changing. With the introduction of integrated corridor management, you see a lot more intelligence being injected into ITS. And that's really good to see, because what that will do, it'll be baby steps, but it will eventually get there. And then as we look forward on that, once you have that, you can start to data mine, you can start to throw up some management telematics. But it has to be said that some of these issues are actually preventing us from managing the environment as we really need to.
Okay, actually we have a question on this slide here. Could you please describe what you mean by management telematics?
Yes, and actually probably I shouldn't have used that word in all fairness. I'm really talking about dashboards. The idea behind this is to actually provide a level of data, a level of intelligence at a glance. So through a dashboard you can potentially identify what's really going on in the network. But it's really one screen giving an overview, a quick overview, which you can then drill down to if you wanted to. But that's what I'm thinking.
One more. Yes, so thank you for answering that question, Jürgen. The second question that I received here is, what do you mean by time-stop data analysis? Surely everyone is monitoring in real time, but how does this differ?
Oh yeah, that's a good question, and perhaps I should have said a little bit more about that. I probably skipped it altogether, so forgive me. Back in the 2000s, I was responsible for looking at real time. At that time, it was purely historic, and there was a huge move to actually start looking at real-time data and being able to get systems to accept real-time data. But real-time data is effectively historic. There is latency involved, so by the time you get it, it's always a little bit old. It may be seconds, but it's still old. But the idea behind time stop is you collect that data, you continuously store that data, and you continually reflect that data against other data you've already got. So for instance, if you're looking at, shall we say, the congestion build-up in the morning rush hour on a particular stretch of road, you may start looking at it at, say, 6 a.m., 6:05, 6:10, 6:15, and it could be in 15-minute increments, or it could even be in 30-second increments, or even less than that if you wanted to. But the idea is you actually build up this profile, and then from the historic, the real-time, you can actually start to identify what the prediction is going to be. And that's really what I mean by that. So in order to get there, how can we actually build this sustainable system that we really need to move forward on this? Now, we really need a sensor to be able to identify every passing vehicle, or at least the majority of passing vehicles, because by doing that we'll get to this microscopic model that we discussed on our last webinar. But the idea behind it is by having this microscopic model, we can actually identify the beginning points and the end points of every vehicle, or most vehicles on the road. Now, we don't need every vehicle, but we do need a majority. And once we do that, we'll collect data from more, we'll need to collect data from more locations to get there. But that will give us an understanding of what has happened, the historic, what is happening in the real time, and what will happen the predictive by using this. And as I said before, by using this in a profile curve, if you like, to identify how it's actually changing, how that event is changing. Once we get to that point, we'll then be able to analyze and to better manage that data. And if we get there, and I think we will, I really, I think we have to, with the congestion issues that we're currently facing, I think, we'll get from this passive monitoring stage to a real active management. But I want to be clear, it's all about the data. The more data we have, the more quality of data we have, and the more we understand that data by identifying the cause and effect, the better we'll be able to really take this forward. So some of the major issues facing camera technology is obviously privacy, and let's talk a little bit about privacy because this is a really big hot topic. As an example, Germany doesn't allow any ANPR applications because of privacy laws in Germany. That said, they do have speed cameras using ANPR. And in fact, I actually applied to the German government to get a test case set up so that we could test ANPR applications as a research project, and nothing more than research project where the data would be destroyed at the end of it. And after much toing and froing, it became apparent that actually the German law wasn't prohibitive, it wasn't defined. And because it wasn't defined, they're reluctant to say yes. But which amounts to the same thing. But by the same token, you've got other countries such as Singapore, and I believe I'm right in saying this, that has identified that dash cams must be used in vehicles. It's no longer an option. You've got places like Spain who've just allowed it to be used. You've got Poland, I think they've also passed legislation to, I don't think it's law to have it, but it's certainly recommended to have them. And then you have this kind of situation where you've got some countries prohibiting it, some countries saying you actually have to have it. But let's look at this logically, just for a second. Anybody with a mobile phone is being tracked. Okay, there are more mobile phones in this world than there are cars, significantly more. As far as I know, there's not any 13-year-olds out there driving cars. But I don't know a 13-year-old that doesn't have a phone. The fact of the matter is, if you have a phone, you're being tracked. If you're going down 2 miles of freeway and you pass one camera, it's a surprise, frankly. If you go down two miles of freeway with a mobile phone, you're being tracked through at least 3 cells. So this privacy issue has to be put into perspective. Yes, there is an issue there, but yes, it needs managing, but it shouldn't be the be-all and end-all of ITS. Communication networks are also very important. As we get higher resolutions, faster frame rates, and better quality of cameras, in all fairness, the bandwidth requirements for cameras is going to go up, so therefore there has to be some kind of mitigation strategy to bring that down to a level which is acceptable again. So that's going to be one of the areas we have to face. Camera management, as it becomes more cameras in the world, we're going to have a situation where you can't possibly monitor 600,000 cameras, and there has to be some automatic processing, not only undertaken, but then relied upon by the operators to actually flag up incidents. One of the things I worked on years ago was identifying which cameras were unavailable, not in use, failed, required maintenance. And we did that just by looking for static on those cameras, as an example. And that can be done very easily through software. Obviously, the cost of ANPR software will significantly reduce any applications out there at the moment. I've been quoted as much as $2,500 for a license, but that will come down. There's quite a lot of competition in this sector now, and that's going to come down dramatically over the next few years. And of course, we have the 2 new technological applications. As new technology comes to place, that's going to have a significant impact as we move forward as well. So,
actually, sorry about that, Jürgen. The question did pop up for the last one. It's really not clear what you mean by new technological applications. Please, could you provide your thoughts?
Certainly. Francis, would you like to say that again?
Okay. I got it. I got through it.
I will go through what this means, but I'll go through it in the next slide. I think it becomes more apparent as we move forward on here. I peek into what my perception of the future is going to be, and it is my perception. A camera, a standard ITS camera, will require a lighting array, will require obviously the camera itself, but it would require some kind of processing capability onboard software onto a processing board. What I'm thinking about for that is really things like the speed, the occupancy volume, vehicle classification, wrong way running, debris on road. They could all be done at the front end. These are all areas where you don't specifically need ANPR because the ANPR is simply too big for mounting on the camera in most in free flow applications at the moment. You're going to have communication networks on there as well. And the reason I say that is because as we move forward, if we can actually do some of the processing on the camera, it means we don't have to send back every image, we only have to send back the data we need. And that's very important, and that will actually bring that bandwidth down significantly. Now, if we do that, what we can effectively have is the iPhone of cameras, or the smartphone of cameras. Let's keep off the branding here, so forgive me for that. I shouldn't have said that. But the smartphone of cameras. And basically the idea behind a smartphone is you have all these applications and you run the ones you want to run when you need to run them. And the same will be for, my vision is the same will be for the camera.
Just a brief question actually popped up. Do you need an IR lighting array if you have adequate high dynamic range or HDR?
Good question. The jury's still out on this. My interpretation is I think you do. There is an argument to say if you have a high enough high dynamic range, the fact of the matter you probably don't need it. I think I would err on the side of caution and put it in anyway and have it and rely upon it. And if you rely upon it, the problem you've got with high dynamic ranges is generally the better sensors that have the high dynamic range, and that increases the cost, which is probably not a good thing for ITS applications anyway. So if it were me, I'd keep the high dynamic range within a sensible environment, a sensible sector. Move my hands around massively, but it's not really helping the webinar. Have it within a sensible area, have a relatively low price sensor, put in a lighting array, and at that point you can guarantee to hit everything. The problem with a lighting array, but the problem with high dynamic range though, for that matter, is that in nighttime conditions, obviously the lighting array will only meet so far the so-called high dynamic ranges. But again, if we have sequencing, that will also help some of that as well. But good question, and please keep those questions coming. So what does this mean for camera applications? Obviously we need to have increased resolutions, increased frame rates, reduced bandwidth, and we'll do that, as I said, by actually doing some of the pre-processing at the front end. The buffering and sequencing. And buffering, by that, what I mean is when there isn't the bandwidth available, the idea is to buffer the data and send that data when there is bandwidth available. And sequencing is effectively exactly what HDR does. If you have 3-shutter HDR, what it does effectively takes 3 frames and then use the best one. What we're suggesting for sequencing is that actually it will either alter the high-risk control, or it'll alter the white balance, or it'll alter the frame speed, just to try and get the best possible image, so to make sure that all data is captured as close to 100% as possible. And then the HDR and WDR, to answer the question as we came up before, allows us to see in almost every condition. And to be clear here, the current camera technology can see about 10 times better than the human eye. And as such, they can see in rain, fog, hail, snow, a lot better than we can. And that's been proven. And as I said, there is one application that I investigated, which is using cameras with back-end ANPR, and over the 3-year period has been able to glean 99.2% of all reads. So that's pretty good. I think we'll go with that one. Multi-use application. And it gives us the ability to collect all data and then therefore that microscopic model we're talking about, which I think is absolutely essential as we move forward on here. As I said, the next element, and it gives us the opportunity again to do the triggering, the automation, and thereafter the prediction. Okay, we have a question.
Quick question here. Could you please define what you mean by operating triggering?
Yeah, I think we hit this a little bit before on the slide with the traffic management center, but the idea behind that is I probably should have used the same word as they use there, flagging, but triggering, flagging are effectively the same. You know, the idea is you have some automation. That automatically brings up screens to the operator saying, okay, we've got an issue here or a potential issue here, you need to look into this. And as we move forward and as we go down this well-trodden path, or not so well-trodden path at the moment, you'll then get the automated decision support system saying, okay, this is the issue and this is the action we recommend you take. Foreseeable issues with this approach. Some of these have already gone through. I'm not going to go through them all again, but the decision support systems I think are going to be critical, and some of those you can already see starting to make an impact on here with the integrated corridor management type systems, which rely on decision support systems, scenario development, and event triggering, really to actually assist the operator to manage the quality and quantity of data they're getting. We'll certainly have to have changes to the ATMS systems to accommodate the data that could be made available from this technology, and frankly from any other new technologies that are going to come to light. You know, at this moment in time, these systems can't accept predictive data; they can only accept real-time data now. So we've gone from only accepting historic to only accepting real-time, and now we've really got to start looking at how we accept the predictive data as well. Because of we'll have a better understanding of what's really happening on our network of roads. We're in a situation where the camera locations that we currently have, the location of cameras we currently have may not be right, because what they're effectively there to do is identify congestion hotspots or accident hotspots. And what we really need to do is identify the build-up, where it starts from. So those camera locations may be beneficial, but there may have to be other ones which actually bring that together. And one of the last things, we have to learn to trust the data we get from this. I've got two examples, but I'm going to concentrate on one. When computers first came to light and were first used in anger, one of the first things they were used for was to identify or to predict the result of an election based on exit poll information. And what it did at first was identify a landslide victory to candidate A or B. I can't remember which one. But it was such a landslide that they wouldn't believe the data. They said it's wrong, and because of that, it never got aired. Only to find out that actually, when the counting had finished, the system was actually uncannily accurate. And we have to actually start. If we go down this path, we have to start to trust that data, and the operators that in traffic management centers have to trust that data as well. Obviously, privacy we've already addressed. But the last one here is change management. We have to get past this whole privacy perception. We have to get past the idea that ITS is about revenue collection and fining people for driving too fast or whatever. It has to go from enforcement to management. That's really important. And we have to go from enforcement to safety, and I think that's also equally as important. This is more about managing our networks rather than fining people because they're traveling too fast. Now, if we manage our networks efficiently and effectively, those people will actually automatically be slowed down anyway. And I think it's really important to actually look at this holistically as opposed to how we have been doing it up to now. So, to answer the old important question, will cameras become a standard ITS sensor? I think it could do. I think it should do. I don't think there's anything out there at the moment which will actually give us level or quality of data that we're currently looking at. And I think it's actually imperative to start getting that data so we can really start to manage that network, to manage that entire network. Will it require back-end system changes? Without any doubt. Now, will it all be done in a day? No. Will it all be done in one time? No. It will take months and potentially even years to get there. But I passionately believe that we will have cameras being used as data sensors on the road in the very short-term future. And I'm talking probably anything from 3 to 6 months. I think we'll actually start seeing some real differences here. If we do it, we'll truly go from active management, from passive monitoring to active management. And if we get there, then you'll start seeing some real improvements in integrated corridor management systems, and that will then breed to evolve to smart transportation, smart city, and active traffic management. So in a nutshell, I think it really will happen, and I think it really needs to happen, and for that reason alone, I think it will. That's the end of my slides, so if there are any other questions, I'll take those now.
Sure. So we do have one that popped up. Are there existing standards within ITS / ANPR for cameras, software, networks? And are they mature or maturing?
Wow, that's a really good question. I'm not sure I have the answer. I may have to come back with some research on this. I'll be honest, standards in ITS are pretty limited. There are a couple of standards which, such as the TMD, the Transport Management Data Dictionary, and the NTCIP, neither of which apply to ANPR, or not apply fully anyway. At this moment in time, I don't know of any standards which apply specifically to ANPR. And in all fairness, I think it's evolving so rapidly, I don't believe that standards would apply very well to ANPR applications. Having said that, what ANPR applications give you is essentially a number plate. That's all. So providing you can identify the vehicle number plate accurately, and it gives you a number plate and it gives you a confidence factor generally. So if the confidence factor is too low, you effectively ignore the number plate and take a picture and actually have it verified manually. But the fact of the matter is, as I said, there are other applications coming to the market now which are identifying a hash code with 128-bit encryption. There's also other ones identifying the vehicle through particular marks on the vehicle, etc. So I don't believe there are really standards at the moment. Will it help? I think at the moment it probably wouldn't. I think at the moment it probably limit some of the technological innovation that's actually happening out there. So it probably wouldn't be the first place I'd look at for standardization, unless we really look to the future and try to standardize what the future would look like. I think at that point you'd see a huge influx of new players. Does that answer the question? Okay, anything else?
Yep, that does answer it. Got confirmation it did. Yeah, so kind of going back to this next question in regards to the traffic management systems and in regards to the change, do you think that they will change to accommodate this new data source, and if so, why?
I think in all fairness, they're not going to have a choice. Some of those changes have already been made to accommodate integrated corridor management. And there's at least 2 organizations that I know of which are actively developing new systems to accommodate that and accommodate the decision support, the automation, and the event triggering that we're talking about. So I think anybody that doesn't, or any organization that doesn't move forward on these kind of new innovations will actually be left behind. And I also think that with these new innovations, you're going to get other companies who haven't been in this field developing systems which are far superior to what's currently out there. One of the problems we've got with the systems that we currently have is they are pretty proprietary, they're pretty old, a lot of them, and they've effectively been tailored to meet the requirements over a course of time. And as a result of that, perhaps their back-end data elements and databases aren't as organized as they need to be within the big data concepts that currently are persisting. So frankly, I think, yes, they're going to have to. And I also think, whilst it won't happen overnight, I think you'll start seeing changes to those systems happening pretty quickly.
All right, thank you. And we do have another question here. know you mentioned in regards to the different the privacy issues and different regions kind of requiring or having different rules. Obviously, it looks obvious that they will require different approaches. Any idea of how they can go about accomplishing this?
Yeah, I don't think that's as hard as it sounds. And yeah, there will be different approaches in different regions. But there already are those different approaches in different regions anyway. So for instance, the Middle East requires a different technology to other areas as well. Germany, as we've already identified, requires different technology. And in fact, one of the technologies I discussed was developed specifically to accommodate Germany. But that said, all it provides back to you is effectively an encrypted license plate, which isn't very different from a non-encrypted license plate, from a systems point of view, as opposed to the plain letters themselves. So yeah, will it be able to accommodate the chip variants, the variations? Yeah, I think they will. I don't think that's as big as we think it is. But yeah, there will need to be changes there. So for instance, but there again, any system which accommodates the license plate at the moment has to accommodate all the different license plates of the world anyway. So so there has to be the ability to actually do that anyway in the first place. Anything else, Francis?
I think that's it right now. Just waiting to see if there's any more questions that pop in.
And how are we doing for time at the moment?
Oh, about 4 minutes, under an hour.
Okay, perfect.
So maybe give a quick minute to see if there's any more questions.
Well, whilst we're doing that, let's just, if it's okay, wish everybody a happy holiday. If those questions do pop up in the next 4 minutes, then we'll answer those. If they don't, then please feel free to drop myself or Francis an email or give us a call for that matter. We'll happily answer any questions you may have. Other than that, anything else, Francis?
Looks like it's quiet right now.
Okay, well, I just want to thank everybody for attending and happy holidays.
Thank you all. Happy holidays to everyone.